All right, let's continue from the last video. Example 2. Let's assume you have an input layer and then you have a hidden layer, and then this is output. So this is input, this is hidden, this is output. Let's assume there are only one neurons. So only this neuron and only this neuron and then only this neuron. First, we will have this guy give Z1. But we know that we are going to have, of course, the input, the target, because we're doing supervised learning, the activation function. You have to select the one you want to use. As usual, let's use the sigmod function. It's easier to use in demonstration. And the learning rate. So these are necessary. And then Z1, so this guy will give you Z1, which is W1x plus B1. And then the output, this guy will receive the activated Z1, and the activated Z1 is 1 over 1 plus exponential minus Z1. This is the input to the hidden layer. So this is the input to the hidden layer, and then this guy will now use this to make prediction. So now it want to use the hidden layer will use this to make prediction. You can also call this H1 because you have to give it a name, H1. So H1, and then H1 will be producing Z2, which is W2H. You can call it, let's call it just H. W2H plus B2, and finally the output layer will receive this Z2 as output. So output is going to be this. Now, how about the loss? The loss, there are two types of losses. There is the loss for this prediction and the loss for this prediction. Now, I'm going maybe here. So L is a half into y hat minus y. Y hat, which is the total outcome, is you can say y hat is just W2H plus B2, but we know what H is. H is this, and we know that in H there is also Z1. So this is why it is a function of a function of a function. Now we already know that. So what is DH? Because we eventually will need it, by DZ1, this would give you H into 1 minus H. I don't want to make the video long, but this you can get this. And then we know that d sigma by, we did it last time, by dz1 is sigma of z into 1 minus sigma of z. We did this last time. And then now we can compute the gradients. So I don't know how, okay, I'll just do it here. Because L is a half into this, so you can easily say dl by dy. How many parameters have we here? We have omega 1 b1, we have omega 2 b2, one for the hidden and one for this means you need dl by db1, dl by db2, dl by d omega 1 for the, so this is for first layer, hidden layer, first layer, dl by d omega 2. And you can get this using chain rule like I explained. Let's make it like this. Using chain rule you can, so dl by d omega 2 is dl by dy times dy by d omega 2, which is y hat minus y times h. Also dl by db2, we already know that from here dl by dy is just y hat minus y, because the 2 goes, and dl by db2 gives you, if you do the chain rule, you just get y hat minus y again, because there's no time, and dl by d omega 1, this will give us I assume that the viewers are able to figure out how it should be, because we don't want the video to be long. So this is going to give you y hat minus y omega 2 h into 1 minus h times x. Also dl by db1, this gives you y hat minus y omega 2 h into 1 minus h. And then we're done with the gradients. Step 3 is the update, or I would say, so the update is just easy. You can say w2, or how do I say, w2 update is w2 minus the learning rate dl by dw2, which we already know. W1 update is w1 minus the learning rate dl by dw1. B2 update is b2 minus the learning rate dl by db2. B1 update is b1 minus the learning rate dl by db1. And these are, that's in general, this is how this short neural network will operate. And if you have more neurons, you are going to have these operations more and more. I will now give another example in another video.